Okay, in this video, we're just going to do two last examples. So let's jump right in. In my first example, I'm going to find this side x. I want to find the length of side x. Again, can I use SOHCAHTOA? In this case, no. I don't have a right angle triangle. I don't know that any of these are 90 degrees. Okay, so if we don't have SOHCAHTOA, we start by labeling our sides. Little p is across from angle capital P, little q and little r. Then we think, can I use sine law? That's going to be our next kind of step, what we're looking to do. Here I can't. Notice I don't have any complete pair. I don't know side r and angle r. I don't know side q and angle q. And I also don't know p and p. So I don't have that complete pair that I need to use the sine law ratios. So instead, we're going to use cosine law, kind of our third option. So we only are going to look at cosine law when it's not a right angle triangle and when I don't have that complete pair. So let's get started. Again, here's the cosine law for side lengths. Here's a version of the cosine law for angles. In class, we talked about how these are really just the same rule, just rearranged. And the letters don't matter. I don't have A, B's, and C's. But what matters is the form or the pattern. So P, Q, and R's work just as well. I'm looking for side P. Whatever I'm looking for is going to go on the left. Then comes the other two sides. So I've got Q squared plus R squared minus 2. Then again, it's the other two sides, Q and R. And then cosine of the angle across from the side that I'm looking for. Okay, now I'm going to start plugging in information or data. So I've got 15 squared plus 9 squared minus 2 times 15 times 9 multiplied by the cosine of 31 degrees. Again, we should only have numbers now on the right-hand side, so I can just simplify. If you have a scientific calculator, you would be able to type this all in just in one step, if you can see what you write, so an Android or something similar to my calculator. But otherwise, we can just simplify. 15 squared is 225, 9 squared is 81, 2 times 15 is 30, times 9 is 270, multiplied by the cosine of 31. And then I can collect 225 plus 81 is 306 minus 270 cosine of 31. Be really careful here. We have to follow order of operations. Sometimes students try to subtract. They try to do 306 minus 270. But using BEDMAS, I have to do my multiplication first. I'm just going to plug it into my calculator. So I have 306, take away 270, multiplied by the cosine of 31. So P squared equals 74.6. Again, if you have a calculator like mine, I could have just typed in this step and saved myself some work, saved myself some steps of algebra. Again, always we want to type in exactly what we see, and I would get the same number, 74.6. Is that the length of this side? No. P is actually going to be the square root. So to get rid of the squared on the left side, I have to square root both sides. And so my final step is to take the square root of 74.6. So P would be 8.6 centimeters. And I could add that to my diagram. Okay, so that's how I use the cosine law to find for side length. We use it when it's not a right angle triangle, when I don't have a complete pair. We're not going to do it in this example, but notice I now do have a complete pair. I now do know P and P. So if I then had to solve for angle Q or angle R, I could go back to using the sine law. And I could always find the third angle because they sum to 180. So we're only going to have to use the cosine law once, at most once in a question. That's how we use the cosine law to solve for side lengths. We can also use the cosine law to solve for angles using this version of the law. Here I'm finding angle C. Again, it's not a 90-degree triangle. It's not a right triangle, so I can't use SOHCAHTOA. So I'm going to label the three sides, lowercase letters, across from their corresponding angle. And I don't have a complete pair, right? I don't actually know any of the angles, so I don't have a complete pair to use sine law, so we'll have to use cosine law. I'm looking for angle C, so I'm going to start with cosine C on the left-hand side. And again, this will just give you not the exact letters to put into the formula, not the exact labels, but the pattern. So I'm going to take my other two sides, a squared plus b squared, and then subtract the side opposite the angle I'm looking for, divided by 2 multiplied by the other two sides. So I'm trying to find cosine of C. Then I'm just plugging in numbers. So A is 9, so I have 9 squared. B is 11 plus 11 squared minus 8 squared, all over 2 times 9 times 11. So again, we shouldn't have any variables on the left-hand side. And again, what I'm going to do is I'm going to simplify the top and the bottom separately. That way I don't need to round midway through the problem. So I've got 9 squared plus 11 squared minus 8 squared. So I've got 138 in my numerator. In my denominator, I've got 2 times 9 times 11. I've got 198. Okay. So that's my cosine ratio for angle C, but I want to find angle C by itself. So to move the cosine to the other side, we have to do always the opposite. And the opposite of cosine is inverse cos. Looks like a cos minus 1 in your calculator. And what that does is I'm going to be looking up this ratio to figure out the corresponding angle. So again, I'm going to click my second or my shift button and then cosine. So that's cosine inverse. And then I can just do 138 divided by 198. And because it's an angle, I'm going to round to the nearest degree. So angle C is 46 degrees. Again, I don't want to divide this in my calculator first. I only want to use my calculator once, really. I don't want to have to round to a decimal midway through the problem. So I'd rather simplify numerator and denominator separately, and then take the inverse cosine of that ratio. Again, I now have a complete pair. So if I asked you to go on and find A and B, you could use sine law. You could also use cosine law. You kind of have some choices. And to find the third angle, you'd always use it. They sum to 180. So that's how we use the cosine law. We use it when we can't use SOHCAHTOA, when we can't use sine law. And I can do it to either solve a side or to find an angle. Again, thanks for watching, and let me know if you have any questions.